So welcome to today participating in LeetCode Biweekly contest 80. So first question is strong password checker. 2. A password is said to be strong if it satisfies the following criteria. It has at least 8 characters. It consists at least one lowercase letters, okay, one uppercase letter, one digits, and one special character. A special character is a character that follows this. It does not contain two of same character in adjacent positions, that is AAB violates the condition, but ABAB does not violate the condition. Given password returns the true if a strong password, otherwise returns false. Otherwise return false. Okay, so we have to otherwise return false. So we have to check. So we first check the password have at least one uppercase letters, one lowercase letters. So uppercase equals to false, lowercase is equal to false, or digit is equal to false, and contain at least one digits, okay, and it does not contain two same characters adjacent. It does not contain two same, so we have to check two adjacent characters. Also special characters equal to false. So alright, then password can be size 0, no password length always be 100. So PL password of size and I plus return false, because this is going to violate the rules that they have additional characters should be different. So also for the now also cases, if character equals to small and character less than equals to z, so lowercase equal to true. Else if character equals to a, character less than equals to z, uppercase equals to true. Else if character equals to 0, character less than equals to 9. So digit characters are also going to be true. Also the digit character, and for the special characters I think it includes all the special characters, so it will be else special character to true. Special characters also true. So return UC and then MC and then BG and then SC. This will be enough to check that. Okay. I love LeetCode. Wrong answer. Why? 1B 1 expected true, expected false. Why false? There is one digit, there is one uppercase letters, there is uppercase letter A, digits uppercase letter. Why false? Expected false. False. The password does not meet the length requirement. Where is the length requirement? It has at least 8 characters. Oh, that problem not no TURL was too dumb. Accepted. Moving to the second problem, which name is successful pairs. You are given 2 points, integers, arrays, spells, and points of length and m respectively. Okay, you are given 2 points, integers, array, spells, and portion, spells and represents the length and m respectively. Spell I represents the strength of the ith spell, and the positions j represent the strength of the jth position. Okay, you are also given integer success. A spell and the poison pairs is considered successful if the product of their strengths is at least success. Return the integer pair of length n, where pair I is the number of poisons that will from the successful pair with the ith spell. So what we have to do, success is 7, so the output is 403. What does it means? That 0th spell 5 into 1 4. So successful if the product of this with 4 pair are successful. The product of their strength is at least one success. So you have multiply from the ones. So 1 1 8. We cannot multiply from the both the sides, so we will just do the binary search and search minimum index in which we get the minimum index in which we get the 3 pairs successful. We get the minimum index get to be successful. So here 3 9. So we will multiply from the x into, see if it's positive, then we will return to this position, and if it's not successful, then we will return to this position. It is also an easy problem, so we have to return the vector. So we have to just search the binary search in the second part. So until you have a space position p and the success s. So for the long let's define long LL here, and also taking in my consideration of LL. So now performing binary search on the array. The first vector answer, this will going to store the size int n is equal to s dot size, n is equal to p dot size, success denoting by sc. So for the I for 1 2 and I plus plus, I will search the number of elements in b that are having product success greater than b. So first I will also sort my array b. Sort p. If it not sorted, so here here the inverse is equal to helper, and a helper we are passing s of I. So sc into s. So s of I going to multiply with that number, and this have to be greater than sc. So function construct going to return an int return a number index size. So here low equals 0, high equals to m minus 1. So while lower less than equals to high, we'll say, and mid equals to low plus high minus low divided by 2. Okay, so if poison of mid into what amounts we are multiplying with the s, mid into greater than equals to sc, then we have find that positions and our answer equals to answer equals to m minus mid. Also the we will try to get the 2 or more close to that one. So equals to mid. So we will try to mid minus 1. We search for the else. So we will go to that is equal to mid plus 1, and in the end we will return just the answer. So mid plus 1, and in the end, so answer of I equals to, which will store all the vectors. Also these parts must be included. Int not, we have to define ln. Here int is necessary, ln. So here we can have the integer overflow. It is possible to we have the integer flow, yes, because success is ln. So here it is possible that we have integer overflow, ln p into s. And for return function, puts returning and none void function do not return a value one has generated, or it's saying so to define the whole function. Next going to be no comparison over character line number 35 here. So it's running. I forgot to return all the answer that I have stored. Also answer does not have, this includes only fourth. There can be integer overflow are accepted. We'll check, yes, accepted. So moving to the third problem, you are given two strings s and subs. You are given two strings s and sub. You are also given a 2D characters array mappings, where mappings I equals to why I have opened the hard one. Oh, they have given two hard problems today. Two hard problems. So these are 64 submission, these are 0 submission till now. Worst rank. So here 65, 96. The score of an array is defined as the product of its sums and its lengths. For example, the score is that is equals to product of its sums 1 2 3 4 5 75. Given a positive integers array nums and integers k, return the number of non-empty sub-array of nums whose scores is strictly less than k. Scores is strictly less than k. Returns the number of non-empty sub-arrays continuous sequence. So we have to return the number of I comma j pair whose sum of scores is strictly if it's less for each I, if we will try to find the maximum j till which we are getting this score less, because if we are increasing this, then our sum is also increasing. If our sum is increasing, then also this I can solve these problems because the score is strictly less than k. So if the score is greater than k, I want to, if its score is greater than k, if its sum into length equals to, so your score is strictly less than 3. It's also the simple binary search problems. So we'll try to solve this one first, then we're going to move to the second problem, because we just have to find the no we have to define here we have to count the number of subarrays. So for every I am getting some j, and the number of subarrays for this particular I is going to be this j minus I plus 1 sum j minus I, because this is a valid point where so is a 1 subarray, 2 subarray, 3 4 5 6 7 j, and for the every I am getting this. So here I'm changing nouns to the v because it's more official to read in my way. So the sum is going to I am going to take from the prefix variable. So vector fx is going to store the sums of some integers. This is going to store this our sum, and I'm making it ln. I'm going to multiply it from the another vectors. So for I and here I'm defining n, so n equals to dot size, n equals to v equals to, so I equals to 0, I less than n, I plus plus fx of I equals to fx of I minus 1 plus v of I. Here fx of 0 equals to v of 0. Here I have created a prefix sum which is going to help in giving me the providing me the sum, and auto function sum is going to give me sum when I give them to indices, index L and index R. This will provide me the sum, that part index x. So our res equals to prefix of R. So L to R, if L minus 1 greater than equals to 0, then res minus equals to prefix of L minus 1 and return res. Here here I'm returning the res. So for now, for each ll answer equals to 0, for each I'm going to do the binary search and find the find that maximum point which we can get the sum. So if v of I is greater than equals to k, continue. Otherwise we are going to do the binary search on this length and we will reach till I strictly less than k. We will do the binary search now. While low less than equals to high, mid equals to low plus high minus low divided by 2. Okay, here the mid is that, and if our mid is this position and we are at, so we are going to find the total sum. Cal c calculate equals to sum in this region. Sum is going to be our I to mid, also going to multiply with the size mid minus I plus 1. This is going to be size. If cal is strictly less than k, we are going to extend this, so low equals to mid plus 1, and our answer equals to low, and our answer is equal to mid is valid is I equals to mid minus 1. So if the answer is valid, we are going to add in our answer rx. So our answer is going to be simply rx minus I plus 1, and in the final I'm just returning the answer, which is the ll. So here changing the integers to ll, making all the elements here ll. So I think it's not going to be run perfectly. Six and five. What about the 10th? If k is 10, the answer is 6. If the answer is 5, 10th answer is 6. Answer is 6 and 4. This one. So should I submit? If I went wrong, I do not know what's still wrong in this. So only tension about the integers overflow. Otherwise, the logic I have written. Accepted. Yes. Now moving to the I think the range is now much better. So moving to these problems, I think how much submission? Oh, it has 263 submissions. I think it's more easy than that one. Oh, you are given two strings, string s and subs. Today we can come under the ranked one. So you are given two strings s and sub. You are given two strings s and subs. You are also given a 2D character array. You are given two strings s and sub. You are also given a 2D character array. Okay, moving to the new fresh page. We have given two strings s and sub. We are given a 2D character array mapping, mapping where mapping I equals to old I and new I indicates that You may replace any numbers of old I characters of sub with new I. In sub each character in sub cannot be replaced more than once. Each character in sub cannot be replaced more than once. Return true if it's possible to make sub as a substring of s by replacing 0 or more than one character according to the mapping, otherwise return false. So we have to just, oh, its length is also 5000, so I think 5000 into 5000 we have to make, okay, we have to map from the old I. So mapping I, why there is the need of the mapping I? You are given two strings s and sub 2D characters, where mapping indicates that you may replace any old I characters of the sub I, any number old I characters with a sub I with a new I. Each characters in sub I cannot be replaced more than once. Returns true if it's possible to make sub as a substring of s by replacing 0 or more than one characters according to the mapping. So for this substrings, I'm going to start from this s and going to check for each indexes. For each index is going to check for the n square times, so it will be 5 into 5 5000 into 5000. So 5000 square will be 5000 square will be more than, how much is going to do? 5000 square is going to be, oh, 5000 square is going to be 1 2 3 4 5 6 7 8 8. So to make it under the constants, we are trying to map is length 1000. So what I can do in this set, map is a vector character of length 2, map I is of length 2, and the characters in this are coming. So we will try to make count. So first read the constants. So s length is now as substring contains uppercase and lowercase English letters and digits. So this will be no more than 256 for mapping from old 256 to 256 to 256. So moving to this also, I will try to map this to the, I will try to map these characters of I to the new, making it available that it can be changeable. So our mapping will be like, we have to make sure first we are going to n square n into n for checking, and for each checking I will try to check if it's possible to map these characters to that part, if it's possible to map these characters to the rightmost part. So from the last to first I have to check where is my pin, where do I make my pin? Okay, let's forward. So let's first try to do what I think. N equals to s dot size, try to map, and we have to make sub as a substring. So sub length is going to be smaller than this. So sub length is going to be smaller than this. I think I can do pretty well n square. And for the character vector I want to mapping with the vectors of 52 vectors in 256 basic ASCII values. Empty going to map with the 257 going to map with the vector of map with vector of 257 0. So our mapping will be in this way. So 0 I less than I plus plus our mapping of I. Each what he has said that each character in survey cannot replace indicates that you may replace any old I characters of survey with the new I characters. Each characters in survey cannot be replaced more than once. So we have to only check when the frequency. So for the example, full 3 lead mapping will be lead. It's to replace the first E in the sub with 3. So it will be 3. Replace the first in the sub with 3 and the T with 7. So it does not have to L3E7 bar lead. So replace the survey here is 3. So we can replace the first 3 with this 3. So we are going to make L3E7. Oh, we just not have to think about how much, and we just have to replace the characters when it requires. Each characters in survey cannot be more than once. Okay, now I understand. So here mapping of this mapping of I, 0 mappings I, 1 equals to 1 means this is going to be valid. So for I equals to S Z size -1 I is less than S and I plus plus. We are going to check for the each characters of this just name it B. B will be more easier to write. So we are going to match the each characters of the B with this one. So for J equals to I, so we just have to match with J equals to dot size J equals to 0, J minus is going to false. So we have to just say match if it is going to minus. So is that if v equals to j or s of pt equals to no, or v of okay v of j to this mapping of v of j comma, but from mapping from this position to the mapping to s position pt equals to 1, then continue, otherwise flag equals to true and break. So if flag is true as well, then in the final return false, return false, because we does not have to take care about the foobar is going to be true, and for this foobar sub mapping from going to be false. It's false. How it's going to be false? If I'm going to replace the third lead, these are the replacements, or these are the replacements. So I'm going to first mute the mic. So what I'm doing right now, I'm not taking the indexes from the last elements as you have seen, so I will be back after the contest will be over. So moving to the explanation part, so explaining all the four ones. So we have performed well today and have one penalty in A because I have not read the constraints clearly that what they are saying. So moving to the first A problem is simple problem. Basically we have to check the criteria. The string password should be strong, and for the string the password should be strong. It should have length at least 8 characters and contains at least one lowercase, one uppercase, and one digits, and special characters are these one. Basically if you see that these special characters are all that possible in our ASCII characters. So now if we have strong password that given string, so we just have to return the true. So it's simply the moving to the code. So it's simply I am making the variables UC upper characters, LC lowercase, and DC digits, and SC for the special characters. So if the password size is first strictly less than 8, so we have to just return false, because our password size should always be greater than equals to 8. So this is a first mistake. I have not read this statement first time, so got the penalty. And simply I'm just iterating now in this. And also there is a case that the password will be bad if there are two same characters in the adjacent positions. So for the adjacent positions I and I plus 1, I'm checking if they are equals, then again I'm going to return the false. Otherwise checking for the character C is in range A to Z, means it's the lowercase characters true, for the uppercase characters in capital A and Z, and for the digits from 0 to 9, and for the special characters that are remaining ones that will be left, and simply returning the AND operations of this. If any one of them is going to be false, then the whole AND operations among this is going to be false. So moving to the second problem of this contest, that is successful pair of spell and poisons. So we have to see that basically there is a concept binary search always comes in every contest. Whenever we have to find any digits in the another array, we can go for the approach binary search. So this is also based on that concept of binary search. For the spelling and the poisons, if we have to just give the counts of numbers in the poisons for a particular spells which product of strength is at least success, means strength should be at least success, means that if the spell I into poisons something index of jth index, this product is at least strength equals to the greater than equals to the strength that is given in our problem. So we have to do, so what basically we can do in this, that we will iterate from all these i's and try to find the lowest pair for which we can get this, and if it's possible for something mid, then it is also possible for the mid plus 1, because I have first sort this, because something multiply with smaller and then it also multiply with some smaller plus 1 delta x that is larger, then it will be more greater. So this is basically what I'm saying, and that's all for this. And what I'm doing is moving to the code. First I have sorted, okay, then storing the answer in the answer vectors, and function I have created for the binary search that will give me the number of elements for this that will give me the number of elements for which the strength I, here I am making the strength I, poison P, and the spells I and the poison P, and the strength is SC. So we have also have to focus on these integer overflow, because SC is here constant greater than integer value 10 power 9. So for each I am just using a helper function which is of log n time complexity, and this finding the mid here doing is that the product of I and this SC, that for this particular SC we are finding, if this product is greater than equals to our strength, then this index mid is also possible. Means this mid is possible, it's also possible for the mid plus 1 and whole till m. So we have to just find for the another left region. For the left region I am shifting from mid minus 1 to find the another answer region. So this all for the second problem. Moving to the third one. So in the third problem we have to match the two strings, and the criteria is that we have given two strings S. First one is S and second one is sub, and we have to make this sub the substring of S. And operation we can perform in this is that if any characters in sub not matching, any index in sub not matching from this S, we can replace this at most only one times from this mapping that we have given here. So if we see the constant here, the constant is in range 5000 into 5000, so it's basically 2.5 something 5000 2.5 something 7. So if we use the STLs of map, then it's also add the component of log. So if we do the searching here, so basically we have to convert this map into a DAG data structure that we can easily find the replacement of this S in order of 1. Then it will be easy for us to do the n square operation in finding this as the substring, and for the character that are not matching we just have to replace in order of 1 to check if it's replaceable or not. So what I have done, I have created a graph of these characters to their maps. So basically the characters they have said containing uppercase, lowercase and digits, that ASCII values is in range 1 to 256, so it's easily comes under this range. So for the safety purpose, I don't know why I have just make this 1000. You can also take 256, it does not change the values. So what I have done is that I have simply first creating a graph. A graph is in range, oh don't know I also taken in here. So let's try to sum it in 256 to check the ASCII character that I am saying 256 to 256. So summating again accepted, means that we can easily take for the 256 range because ASCII values is in that range. So for this purpose I am creating map for the mapping that we have given. I am just simply rename the variable because it's too large mapping to write in this form. So here I am creating map from this old to new. They have said that we can replace from this old 0 index to this ith index. Okay, from old to new. So just I have created graph, and for the any character I have to check from this old position to this new position if it's possible, so it can easily be found in order of 1. So this is the best graph data structure that I have used here. And in the n square what I am doing is I am started from the b size -1 index in the s array or s string ith positions, and for going to its till length n, and in s array I am starting from the b size. B is the that sub array that we have given in that time, and simply pt is our pointer of this ith index pt, and we have to just match for the whole from j equals to 0 to j equals to pt. This will be of size of the b dot size -1 if we count. So what I'm doing, if these two strings are already equal, we does not have to swap, we does not have to change this character in the b, or otherwise if these are not equals, then we have to check if it's anyhow possible to change these characters of bi to these characters of s. So we have to check in our graph that we have created first in upward. So if this is 1, then simply I'm continuing. If this is not 1, then I'm making my flag equals to true and break. If anyhow my flag is false, means all the characters we have passed here is going to be matched from the string s. So simply I'm returning true, and in the last returning false if does not match, and our loop is been ended. So this all for the third one. Moving to the problem fourth. In the fourth problem, we have to count the subarrays with score less than case. If you observe that we have got the two problems of binary search into the answer. This also is based on the binary search. We just have to count the number of subarrays whose sum product is strictly less than k. So what we can do is this, that again the concept of the same problem that we have solved the second one, where we have to find the larger. Here we have to find the strictly less. Again we are going to do the same operations, but in a optimal manner, because in optimal manner we have to find also the sum. So first what I have done is that I have created a prefix sum vectors which is going to store the prefix sums. This will be help in finding me give me the range of the sum of particular I to j, sum of particular, or sorry, L to R. So this will give me the sum in order of 1. Okay, and if we try to find for each element s of I, and try to first I'm going to explain the brute force solution, then we will move to the optimal mark. So for the brute force, what we have to do is that we have given array 1 2 3 4 5. So for the each I, we will try to check if it's less than k. So if it's less than k, then this will be going to count in our one of this answer subarray. For this 2, from starting from the I, this is the another subarray that starting from this 1, and for this 3, if it's less than k, if this sum into length 3 is going to be less than k, then this will also going to be in our answer. So for anyhow, if we reach this 5 and moving to the 6, and if we are taking 6 and making sum from 1 to 6, and our sum into length 6 is greater than equals to k, then we have to not consider this 6th position, we have to just consider till 5, and till 5 we have got 1 2 3 4 5 subarrays that are starting from the 1 value of 1. So we have get a 5 subarray. Again we have to do the same operation for the second one. For the second one, we have to again start from the 2 and see if 2 is less than k. Again for this 3, taking 2 plus 3 into that size length of the array is here 2 into is, if it's less than k, then consider this. If it's 4, then consider this. This will be of order of what we have say, if this is order of n square. If we do it optimally, taking this one and maintaining the sum, and for the particular index j, if we come and it's less than k, then break, otherwise we have to take this index j. This will be order of n square. So to do it in better approach, so what I have done, again have done the binary search in the index of array vi that we have given. I have changed the array names as vi and the k which we have given here. So again doing the same for, if the value of vi is firstly greater than k, then we cannot do any operation because the first element is itself is greater than, they simply continue from here. Otherwise answer will be exist, which we going to be add in our answer. So low is here I and high is n minus 1. So rx is going to be considered the maximum point till which our sub arrays into its length is going to be strictly less than k. So for this I'm checking for mid, this mid, calculating the sum from I to mid into the length of this sub array, that cal is here. So length of this array mid minus I plus 1. So if this cal is less than k, then we can means that this mid position is true for us, means good for us. Again binary search, moving to the next mid plus 1 and check for this region. Simply if this is not, then simply again come to the mid minus 1 again, and in the final I am going to consider the answer adding the length of the subarray data starting from this ith index, which will be rx minus I plus 1, and simply returning the answer. So that's all for all the 4 problems. See you later in the tomorrow contest in the morning, which will be again the LeetCode. So have a good day and bye.